today's class we are going to discuss Fischer and Haworth projection of glucose. So we have three structure here. This is your open chain structure. This is your open chain structure of glucose having 6 carbon atoms. Open chain structure, and in this open chain structure this is called pentahydroxyaldehyde. Pentahydroxy mean, as you can see, there are 5 OH group, 1 2 3 4 5 OH group and 1 CHO. So this is pentahydroxyaldehyde, right? Aldehyde. And pentahydroxyaldehyde having open chain structure. What is the meaning of D? What is the meaning of positive? What is the meaning of alpha, beta? Everything we are going to discuss today. And this is your three structure in which Fischer projection and Haworth projection. Fischer, this is your Fischer projection. Fischer projection. This is your Haworth projection. Haworth projection. And now we'll study how to make the Fischer projection from this open chain structure, right? So this is CHO. We are discussing here CHO. We can write down CHO like CHO double bond O, and 1 2 3 4 5 6 carbon atom are here. 6 carbon atom, and right left right 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 left right 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 right. Okay, so this is your open chain structure of glucose. Keep in your mind the carbon number 1, carbon number 2, carbon number 3, because CHO is strong group. So 1 2 3 4 5 and 6. Lowest asymmetric carbon. Your lowest asymmetric carbon mean lowest carbon is number 6. So this is not asymmetric because there is 2 same hydrogen atoms are there, as you can see H2, right? This is your lowest asymmetric carbon because at that carbon all the 4 bonds are different, contain different atoms or groups. Like this is different from this, these are different from these, and these all are different from these 3. So this is lowest asymmetric carbon, and as you can see the OH at the right hand side position, so this is called D. D always designed for configuration, right? D mean configuration, and the sign positive mean it can rotate plane polarized light at right direction. Okay, so this is D positive glucose. D positive glucose. Now you can easily understand the meaning of D and positive sign. D mean configuration, which represent the lowest asymmetric carbon number 5 has OH group at the right hand side, and the sign positive means that it is dextrorotatory, mean it can rotate plane polarized light toward right. Okay, now we are going to make a structure called Fischer projection structure. Very easily you can make it like this bond break in toward O, mean oxygen, because oxygen is more electronegative than carbon. And in this case OH, this bond break toward oxygen because oxygen is again more electronegative than hydrogen. So O negative. Now you can write down O negative, and this hydrogen you can place here. Okay, second number, third, fourth, fifth, and your sixth one, CH2OH. And after breaking bond, this H positive move toward this oxygen atom because this is negative, this is positive, right? And this is your OH, and this oxygen can make bond from this to this carbon, because when this bond break, this will be positive, this will be negative, right? So positive will link with negative. This is negative, so this negative and positive link with this, and all of other are remain same. H, this is OH, right? This is H, this is OH, this is H, and this diagram contain numbering like 1, 2, 3, 4, 5 and 6. So this diagram is called Fischer projection, in which alpha and beta are designed. Alpha D positive glucose, this is your alpha D positive glucose, right? Alpha D positive glucose, in which alpha represent what is the meaning of alpha and beta. All the cyclic structure contain alpha or beta, right? Alpha mean C1 carbon, C1 carbon. Please see the C1 carbon. This is your C1 carbon which has OH at the right hand side. This represent alpha. If this OH will present at the left hand side, then it will represent beta, right? So C1 carbon which has CHO is the strongest functional group in all of these, and CHO having OH functional group at the right hand side mean it represent alpha. If it is at the left hand side, it will be beta. So this is your Fischer projection and naming alpha D glucose. Now you can easily understand the meaning of alpha, what is meaning alpha, what is meaning of D, what is the meaning of positive. So alpha represents cyclic structure and having having OH at the C1 carbon at the right hand side. Okay, and the D mean configuration. D mean configuration, and positive sign represent dextro rotatory nature of the molecule. It means it rotates plane polarized light toward the right. Similarly, the beta mean C1 carbon in especially in glucose, because glucose having C1 carbon contain aldehyde group at the C1 carbon, so which is the strongest group. So this is C1 in case of glucose. So if OH functional group is present at the left hand side, it is beta. L mean configuration, which represent that C5 carbon, that is the lowest asymmetric carbon, contain OH toward left, and at the meaning of D mean configuration mean C5 carbon. At the C5 carbon, which is the lowest asymmetric carbon, here the OH is toward the right, right mean it is D. If it is present toward the left, then it will represent L. So the meaning of alpha D positive, beta L negative, which represent what negative represent, this is levo rotatory nature of the molecule, rotatory. You can check the spelling also. Okay, this is the Fischer projection. Now we will discuss the last one. Last one is your this molecule. This molecule represent the Haworth projection. Haworth projection, the name of scientist Haworth, the name of scientist Fischer. Haworth projection represent all of these carbon atoms like 1, 2, 3, 4, 5, 6, right? Haworth take pyrene as a molecule, to represent the structure. So the real formula of pyrene is this. This is the formula of pyrene, which contain double bond at these positions. So this convert a similar structure of glucopyranose, by the help of which he clearly show the structure of glucose. So C1 is your this carbon, C1, 2, 3, 4, 5 and 6. All of these 6 carbon are represented by these numbering. So C1, the right hand side OH, always present the right hand side OH जो है right hand side present at the bottom, right? So right mean bottom, left mean top. As you can see, right mean again bottom, and at the number 5, this CH2OH always represent your numbering 6 of carbon, and 5th position is this carbon, and the hydrogen you can see here. So it is very easy structure of alpha D positive glucopyranols. And you can also write down Haworth projection structure of the molecule glucose. Alpha mean asymmetric, sorry, alpha mean C1 carbon and OH are present toward the right, or you can say toward the bottom. So this is your alpha. D mean this is lowest asymmetric carbon, mean fifth carbon having OH at the right. So this is at the right. Okay, and positive mean it is dextro-rotatory nature. So this was the all the information of glucose. And carbon, that is C1 carbon, which represent alpha and beta molecule according to position of the OH group at the right or the left. So these are called anomers. These are called anomers. So Fischer projection, Haworth projection are completed. So our next case is Fischer and Haworth projection of fructose. Fructose is a same molecular formula C6H12O6 with glucose, and the word taken from fruits. Fruits mean it is also called fruit sugar. It is also called fruit sugar because a lot of fructose are taken from the fruits. Okay, and you can also see cane sugar, honey, which also contain fructose in large amount. So this is your fructose, and as you can see the formula, and you can easily represent the fructose with pentahydroxy mean there are 5 OH, 1 2 3 4 5 pentahydroxy, and this is not aldehyde, this is ketone. So it is called the definition called pentahydroxy ketone. And now we are going to numbering. Again same numbering, 1 2 3 4 5 6 carbon. Why the numbering start from this? Because ketone is a strong functional group, therefore numbering start from this carbon, 1 2 3 4 5 6, right? And this bond now break in this direction. So anomeric carbon is not the first carbon because see, this is the strongest group. So anomeric carbon is C2 carbon right now, right? So C2 carbon is anomeric carbon, and at C2 carbon the position of OH group in Fischer projection, as you can see the bond dissociate in this direction. This whole group you can place at this position, as you can see here, right? And this is again same theory. OH, this is OH, H come from fifth carbon, this one, same as we have already studied in glucose. So this O are linked with this C according to this situation, like this. And as you can see the numbering 1 2 3 4 5 and 6 OH group at C2 carbon. Why C2 carbon? Because this is anomeric carbon now, because of the strongest functional group C double bond O, that is ketone. So OH at the right hand side, so it is called alpha. If OH present toward the left hand side and all the CH2 OH present toward the right hand side, so this OH if present toward the left hand side of the C2 carbon, it is recognized as beta D negative fructose. Negative sign represent this is levorotatory in nature. All the fructose are levorotatory in nature. So these are levorotatory nature, right? And this is the furan structure. Furan structure you have seen, like this is your furan. This is your furan structure. This double bond. This is furan structure, and the similar structure represented by the Haworth to represent fructose molecule is like this. Again, as you can see, the carbon number 1 2 3 4 5 6, the carbon number 1 2 3 4 5 and 6, right? Again the OH toward the right, toward the bottom, toward the left, toward the top, toward the right, toward the bottom. Okay, and again CH2OH always contain at the numbering 6. Okay, so this is your alpha D negative fructofuranose, and it is your Fischer projection according to the name of the scientist Fischer, and this is your Haworth projection. Haworth projection by the name of scientist Haworth. So pyrene and furan represent the Haworth projection, pyrene and furan to represent the whole molecule. So hopefully this could help you. This video could help you, and the meaning of alpha, beta, D, L, positive, negative represent the molecule of glucose and fructose are easily defined. Okay, if have you can easily see here all the OH are present toward the right, and this is toward left. This is stereoisomerism, and you can study in stereoisomer. If the position of OH can be changed, the structure of this will not be a glucose, it will be a mannose, and the position of 1, 2, 3, 4, fourth position of OH will change, then the structure will not glucose, it will convert in galactose, right? So this is the full explanation of glucose and fructose, the Fischer and Haworth projection of glucose, the Fischer and Haworth projection of fructose. Thank you so much for the class.